The SIR model is used to model the spread of disease in a population over time. It is broken up into three main compartments: the suspected, the infected, and the recovered. The change from the suspected to the infected is modeled by alpha, and the change from the infected to the recovered is modeled by beta. To find alpha and beta, you must find S prime, I prime, and R prime. In the upcoming equations, K will represent the days, 1 over K will represent the recovery rate per day, P will represent the percentage of contact, and Q will represent the transmission coefficient. The equations used for this model are as follows. To find the instantaneous rate of change for the recovered, you use equation 1 over K times I. 1 over K represents the recovery rate per day times the infected. To find the instantaneous rate of change for the suspectable, you use the equation negative PQSI. And to find the instantaneous rate of change for the infected, you would use the equation PQSI minus 1 over K times I, also known as alpha minus beta. In these equations, A can be used to represent P over Q, and B can be used to represent 1 over K. Suppose the Twin Cities metro area with a population of 3.32 million experiences an outbreak of a strain of RSV that everyone eventually recovers from after 10 days and grants lifelong immunity once recovered. When the epidemic was first declared, 50,000 people were infected and 45,000 people were already immune to the disease. Suppose that a suspectable person has a 0.0004% chance of contacting a member of the infected population, and if contact occurs, 1 out of 25 people will fall ill with RSV. Before we get to the question, it is important to analyze the data. It is known that the recovered of the population is 40,000 and the infected is 50,000. Thus, doing some simple subtraction, you can find the suspected of the population to be 3,230,000. B, or 1 over K, is going to be equal to 1/10, or 0.1. P, when made a decimal, is going to be 0.000004. This comes from the 0.0004% chance of contacting. Q is going to be 1/25. This comes from the 1 out of 25 people will fall ill with RSV. And A, or P times Q, is going to be 0.000016. The next step will be to plug these values into the equations we found right here. So, when we do so, S prime, which is going to be equal to negative A times the suspected times the infected, is going to be equal to negative 0.000016 SI. I prime, also known as ASI minus BI, is going to be equal to 0.000016 SI minus 0.1 I. Again, the S's represent the suspected and the I's represent the infected. R prime is going to be equal to 0.1 times the infected population. Now on to the question. The question at hand is, what are the populations of the various compartments on day 1? We will only focus on the suspected amount of the population. To solve this, we will need to use the formula S new equals S old plus delta S. Delta S is going to be represented by S prime times delta T. This is derived from an average rate of change problem. Delta T is going to be equal to 1, since the T final minus T initial is 1 day. Now what we need to do is solve for S prime. To do so, we will use the equations that we had previously, right here. So S prime is equal to negative A times the suspected times the infected. This is equal to negative 0.000016 times 3,230,000 times 50,000. This value comes out to be negative 25,840. This represents the instantaneous rate of change in the population over 1 day. Now that we have S prime, we plug that into this equation right there to solve for the S new after 1 day. What we do is set S equal to 3,230,000 plus negative 25,840 times 1, and this value comes out to be 3,204,160. This represents the population the amount of the population that remains suspectable after 1 day. Using the model that we just used to solve for the suspectable, we can also find the infected and the recovered. The infected was found to be 70,840, while the recovered was found to be 45,000. After doing all these mathematics, it is now known that after 1 day, the amount of population that is susceptible to disease is 3,204,160. The amount of the population that has been infected by the disease is 70,840, and the amount of the population that has recovered and is now immune from the disease is equal to 45,000.